Hello guys, welcome to my YouTube channel. Today we will discuss one PYQ question from Machine Learning Foundation, and this is a very important question in exam point of view. So the question is, so the question is, consider a subspace U which uh, which belongs to R3 and a vector B which belongs to R3 space, where U span these two vectors, where our three-dimensional space is spanned by these two vectors, which is a subspace U, and B is a one vector in R3 plane. Okay, and based on the above data, answer the sub questions. So what we have to find? We have to find the projection of V onto U. So let's visualize this problem, and I have drawn a plane which contains these two vectors, because these two vectors uh, lies in a subspace U, and which can be denoted these two vectors. Let's suppose this is a 1 1 2, and this vector is 1 minus 1 1, and we have to find out the projection of this vector x onto this plane, this subspace U. So I have drawn a perpendicular line from this vector on this plane, which is a OA, which is perpendicular to OA is perpendicular to AX, because this line is perpendicular to this plane. So OA is perpendicular to AX, and I have drawn a OX line from O. I have drawn a line joining this vector. So this OA line is projection onto this subspace of vector x. So we can write from this graph, we can write OX, which is this OX is equal to OA plus AX vector. So and OX can be denoted as x, and OA can be denoted as, because in this subspace any vector can be represented as a linear combination of these two vectors, 1 1 minus 1 and 1 1 2. So I have assumed that the coefficients are lambda and mu, which is lambda times of 1 1 2 and mu times of 1 minus 1 is equal to vector OA, because any vector in this plane can be a linear combination of these two vectors. So plus AX vector. So this is equation first, and now we will take dot product on both sides of equation 1 with 1 1 2. So I have taken a dot product with 1 1 2, and vector x is nothing, your vector b, 2 0 minus 4. So I write it down, 2 0 minus 4, and taken dot product with 1 1 2 on both sides of equation 1. So and because and this is 0, because AX vector AX is this vector AX is perpendicular to these two vectors, these vectors, spanning vectors, both because it lies in this plane, and AX line is perpendicular to this plane. So these two vectors are perpendicular to AX. So if we take dot product with AX, so since AX is perpendicular to 1 1 2, so the resultant dot product of these two vectors will be 0. So this is 0, and I have taken dot product, which is minus 6, and these two, if we take dot product of 1 1 2 with 1 1 2, so this is 6 and this is a 2. So So this implies that 6 lambda plus 2 mu is equal to minus 6, which implies that 3 lambda plus mu is equal to minus 3, and mu is equal to minus 3 lambda. So now we have got one equation. Okay, and now take dot product on both sides of equation 1 with 1 minus 1, because this is also perpendicular to ax, vector ax. So we will take dot product and got this equation and equation third. And so using this equation and equation third, we will calculate the value of lambda and mu, because there are two equation and two unknown. So we can easily find out the value of lambda and mu, and the calculated value of mu is 0 and lambda is minus 1. So we can easily find out vector OA, because OA is a projected vector, because if we take projection of this vector onto this plane, so OA is the resultant vector. If we draw a perpendicular line from this vector, the OA is our projected vector. So the OA can be represented, OA is represented as lambda times of 1 1 2 and mu times of 1 minus 1 1. So we are just substituted the value of lambda and mu, and got this, because this is 0, mu is 0. So our answer is OA vector, which is minus 1 minus 1 minus 2. So we can easily find out this vector projection of V onto U. So the actually our B vector is x, so this B is x. Okay, so our answer is 1 minus 1 minus 1 minus 1 minus 2. So if we check the answer in our PDF of this PYQ, so this is our original question, and this is our answer, minus 1 minus 1 minus 2. So our answer is correct. Okay, and one question is there: find the length of the error vector E B, which is B minus P, where P is the projection of B onto U. Okay, so we can easily find out this as well. Find out the length of error vector, which is B minus P. So error is nothing but B minus P. This vector, this x vector, this is error B minus P. Okay, so we can easily find out the error vector. B is our x vector, and P is our projected vector. So we can easily find B minus P and got our 3 1 minus 2. So the error is under root 14, which is 3.74. Thank you.